How's it going, everyone? Eulier Gonzalez. That's right. Today we're going to now talk and explore about this particular topic of Git. So once we already know what Git is all about, the introduction of Git in previous videos. So now let's going to look at the Git basics and the branching, merging, and rebase strategy. So why am I looking at this? Because the whole point of using Git, which is one of the tools that you're gonna use a lot if you intend to be a software developer, if you want to be now a developer, right? And you want to collaborate with others, which is at the end of the day, that's the reason why we are actually using this tool, is because we need to at least understand is the 80% of that tool and be able to describe and also code and understand what it's doing behind the scenes, so then we can now cover the 80% of the cases. So looking at the 20% of the use cases and concepts, so we can get the 80% of that. Why is that important? Because at the end of the day, we want is to at least be comfortable enough with all of the entire tool, right? So we can be effective and efficient in our daily life using this tool. So Git. The TLDR is that Git was a tool developed by Linux because he is so brilliant and we are just mere mortals that he can now hold the entire kernel system design on his head, right? So we can barely now have at least his ability or his skill, right? And this is, make a quick pause here, and this is part of the reason or the tech lead role. So it is someone that can now someone that can hold his entire system on his head, and then when he needs, when a change needs to be done, he know where to look, and he know what to do, and so on and so forth. So in my previous work, I actually worked directly with the TL. So he helped me actually is to know where I need to look to make a change, and that was quite powerful and fantastic. And also that at the end of the day, most of the time those features needs to be developed at a time, right? So yeah, you might have all of these particular tools and techniques to improve your code readability and provability and make your code easy to debug and test and maintain, but also you will need to provide is the outcome for your customer. You need to deliver it at the end of the day. So this is where we are, all right? Now, so Git, let me actually move here. So this course is actually pretty short in regardless to other courses out there. So we describe here the introduction, we went through that. So what is the Git, and I mentioned before. Also we're gonna get familiar with man, which is the manual command, so we can get into that and get used to how to use that. And also how perhaps you do weird stuff on your keyboard when it comes to move around the cursor manual. In fact, let me actually move myself from, so Git master here, that will apply right now, navigation, plenty, Git essential, here we are. Okay, let me do this. Now let's going to jump to the Git essentials. I'm not sure he's pointing that right now. Git essential cursor. Really? Oh, because it's warp. Exactly. It's this one. All right. So here we're just going to recap of what we have learned so far. And that is, here we can use man to actually inspect Git. If you have installed Git, good. If it's not, you can also do this as a way to search for a particular command. You say, hey, I want to search from a particular pattern. Let's say is the C, I want to say C. And now you can actually see is that, right? So I want to see is O, exactly. So highlight me is all of those that start with C, right? And you can move on up. You can move up and down, line by line, up and down, exactly, page by page, right? You can move up or down, up or down, and also you can move through that. Here, that's actually because we can see is how we can move through this. All right, this manual here. Perhaps they change something like for forward one line or key. Okay. So yeah, so the point of this is we are getting quite familiar with this. So you can go one line, or you can go the entire line above. Now pattern was found. You can go here. I can say, hey, I don't want you to continue to search from that. That's interesting. I just want you to move this down per page or per page. Okay. You can move up or move down one line. You can move on or go line by line. You can see the help here. All right. And the particular pattern that you want to match here. You say, hey, search forward from end of matching line, or for search backward. For that, you can go from to look at the next occurring or the previous occurring. Okay, that's quite interesting. In there, only matching lines. Okay, this is another pattern here. You can put it here. So for example, hey, I want to go here and say display only matching lines, right? So say, hey, I'm gonna go here and say, oh my god, exactly. It's like doing this. It's a display matching pattern, right? Pattern not found, so no problem. But you can see that you can search for particular patterns here. Okay. Now, one line, one window, F and V, F and V. Okay, so for example, you want to move from one line to one window. What is this? One line, so one window, move down or up. Okay, move it down. If I want to go to forward one line or forward B. Okay, forward one window to see you that. That's when you started to get yourself familiar with this, because it's quite weird, especially how you can move around this. All right, and if you want to go down, you can go, no. And if you want to go down, you can go to this or this, right? Moving forward, moving backwards, moving up one window, moving down one window, or you can say moving one line or moving down, right? So here you can see is how started to see how you can move around this manual, right? Okay, so that's not the goal of today's video, and in fact it's just to move on into that. And now when it comes to describe Git, that Git is a decentralized version control system, which means that you can have now a local copy of your application that you, based on that commit, recreate the entire project. This is something that might not be quite intuitive, because you might think that those commit actually store is differentials. No, but at the end of the day, they store the entire local copy at that moment, right? So this is something great. And also we're going to look at the Git architecture. That is, it has Porcelain and Plumbing. So Porcelain commands, those commands that you can have access to, that you are recurrently using, all right? This high level command or user command, then the Plumbing, all right? So we're going to look at most of the Porcelain, but more importantly is that how Git data structure works behind the scenes. So you don't get confused when you need to, for example, is do a merge or a rebase or cherry picking, right? So this data structure that is using behind the scenes is known as an acyclic graph. It means that that graph doesn't contain any loops, all right? And it can grow and grow and grow, right? This is a way of how now Git keep track of stuff. And also some key concepts to get yourself familiar of the Git environment, the Git ecosystem. So you are now is the repo, which is the project that Git keep track of. The commit, which is something that we explained that you can now recreate the entire project based on that commit. We also have now 3 stage areas. So the on stage or the on track, the stages or the index, and then the track element, which is once you make a commit, all right? Also the squash. So if you make several commits, you want to squeeze them into one. And something that I mentioned before, which is an on track, stage, and track. You can think of this like a Hanoi Tower, where you're gonna put, or in preschooler or in kindergarten. So when you put all of your stuff here and this and that, you have 3 places where you can put now all of this. Perhaps you are building some sort of tower with Lego block, or with some of these blocks, right? So you have now a pile. You have 3 different piles, right? The on stages, the track or the on stages, the stages or the index, and the track. Something that we're going to look at later on. And some of the Git key facts here that I mentioned before. So now it's an acyclic graph. Each commit is a node in the graph, okay? And it is each pointer to a child to parent relationship. So anytime that you create now, it creates now this parent to child relationship, all right, on the graph. And if you, of course, delete on track files, well, they're gone. They are not in the periodic table. They're missing elements. All right, good. So because this course is for those who are not familiar with things like rebase, which is something that I am, rebase, reflow, log, cat file, config, and reset, because most of the time the command that we're going to use is that get the status, commit, so check the status, the add, commit, and push and pull, right? This is the 5 commands that if you know how to do this, you will be very, very good at doing this kind of stuff, and you will be very, very dangerous. Uh, Now, uh, this I noticed to me was quite relevant in terms of understanding that as we move on in any project, all right, there are a couple stuff that are going to be hard to deal with. One of them is the poor decision that we make in the past. This is one of the reasons why I'm actually is getting exposed myself to this kind of tools and what is the value that I'm getting from this. So try to make me from the future and the clients and the college and all the people out there, well, um, those poor decisions that we make in the past doesn't have any effect on at all, or at least reduce the amount of that long-term consequence. And the other is working with a lot of people in a distributed environment when you need to collaborate in huge, large code bases across different teams. So we went first to look at the Git config to actually look at the particular formats, which is the Git config, the Git, the config, and then you pass the get and globals and yada yada yada. And that is now organized in a section. So when you're going to put all of these, when you want to set up all of the configurations on your users, or when you want to have access to the Git config, you need to follow is this particular format, which is the section as well as the key, right? So we look at how to access that. So Git config get and global, all right? And one interesting stuff is that once we create our Git basic, which is the repo here, right? Which is with a very silly example here, as you can see here. So Git init. Oh, you're not able to see that. My bad. My bad. My bad is here. Let me actually zoom in this a little bit. Okay. So once we started to with the Git basics, it's like, hey, we're going to now use this tool. So we create a project for that. And anytime you now use the Git init, it will create now a Git folder behind the scenes. And this folders is where it's going to keep track of all of the file changes and content. Now, again, I'm still looking at this, and since with Git init, which is something that we did here, is sometimes it might throw you this kind of error, okay, to say, hey, I need you to tell me what is the name of this branch, the default branch, because they want us to rename that in terms to say, hey, I don't want you to call this like master or slave. I want to call it like main and that kind of stuff, right? So the problem is that create a new Git repo and then find the directory in that. So we did that. Okay, as you can see here, if I go to the console right now, let me actually zoom in a little bit. No, how can I zoom in? Okay, you got it. And then I can say, hey, because we already created that, there's already some content here, first MD, and I can say, hey, find all the folders here, right? And here we create all of these different data structures and folders. There are some personal comments that the Prime Gene mentioned of hooks that you shouldn't, is not a big fan of that. In other words, that's what your CI and CD server, or your CI/CD pipeline should be. You know, it's for checking that kind of stuff. But in any case, there are some small use cases for that. So for example, Husky is one tool that allows you to now keep track of, or at least to detect when somebody is pushing a PR, and then apply some sort of rules, some sort of bash rule. Okay, so hey, I want you to follow these templates, or I want you to check these files, and so on and so forth. Or run your tests before deploying that into the CI/CD server, right? But in any case, the idea here is, or the aim is to, instead of sending that to a server and run those CI/CD, for example, test and build process on somebody else's machines or on those cloud provider machines, it's better for us to run that locally and then on those machines. But in any case, yes. So now that we did this, okay, let's get into this problem. We want to trace the steps of Git from on track to on track. We already did this, and that is, it's like, hey, because we already add those changes, as you can see here. One way to remove that, you can say, hey, use catch file to on stage. I want to now remove is the first MD. Error, the following file has changed stage in the index. Use catch to keep the files or force to removal. Git status. Oh, is it still there? Oh, change to be committed. Use git remove catch, the name of the file, to on stage. Okay, that's quite interesting. It's like it catch this, so you can figure out that behind the scenes, this acyclic graph is now catching stuff. Is somehow storing that. So if we double check now here with git status, you can see is this one. You say, hey, now I am on the on track stage. If you remember the previous example that I made from kindergarten, you have now 3 stacks, 3 places where you can now create or build your own block tower, right? So here you have on the right side, from your perspective, the on stage, all right, which is, if you delete this file on the on stage, you will lose forever. It will not be on the periodic table. It's like gone. This one, right? The other is the, how do you call it? The stage, all right, or the index, which is interesting because it tells us here, error, the following file has changed stage in the index. The index. So if we want to now add it to the index, we do this to add all of them, or in our case, it's just the first MD. So far so good. If you want to take a look at the content itself, I am not how to do that. So you can say, hey, git interesting, or you can say is cat file, but cat file doesn't exist, it's not a command. You can say git cat file and first MD. It seems that only 2 arguments allow in the type object, not 1. You say the type and the object. Okay, so let's get into this.
This is pretty much the 80% of you'll do with Git. If this is all you ever learn about Git, you'll be moderately successful. Like, you can get pretty dang far knowing about git add, path to file, or a file pattern, git commit, -m, and then git status will just say -m in a file called first.md to check the status from untracked to tracked. So here's the don't of Git. Friendly message. All right, right here, untracked file. Git has no idea Isn't that kind of disappointing? Like, you know, the author name, the time, the contents of the change, all that, and we'll produce out a SHA. Did you know that SHA stands for Secure Hashing Algorithm? Isn't that kind of disappointing?
Will commit changes that
Like,
are present
it's a
in
variant
the
of
index.
MD5. Either way, it just is always disappointing to add. First to first.md, I'll go hello fam, there we go. On a singular right here. What branch you're on, nothing to commit. There you go. The tree is clean. So the changes are in the repo. One of the common activities you should get into the habit of, or at least know it's available, is git log. Git log allows you to look at the history of the repo.
Okay, so let's get into this. Basic commit SHA. All right, there you got it. It's like a git add will add those files to the index staging area, like that. So git commit will turn your index file into a commit that will have the author name. Especially when you git add will add those files to the index, to the staging area, which is something that I already mentioned. However, when you make a commit, which is something that we haven't done that right now, okay, it will have now the author, the timestamps, the content of the change, all of that, and will produce a SHA, secure hashing algorithm. It is a variant of MD5.
It's a very powerful thing, and we're going to go over a few of the options today, and we're going to use it very regularly throughout this course because it's just awesome to have in your bat belt. I guess we're going with Batman themed things. Anyways, so review or explore, check out man git log. This, I want you to open up the man page and actually look at it, and I want you to search for -- graph and -- decorate.
Did I add that commit?
And there you go. So we with you man git log, look at it, and I want you to search for -- graph and -- decorate.
Okay, so let's going to now go to this. Say man git log. All right, and say show commit logs. All right. Show the commit logs. List commits are reachable by following the patterns like the given commit. And you show that into
and just kind of do a quick read. Get kind of used to reading the manual. I'll do it along with you. Man git log. There's
and then I want to go to the graph, and there you got it. Cannot combine with graph. Oh, graph, and there you get it. Oh, this is again. What I did here is just to get myself familiar with this manual. Okay, makes a lot of sense. Okay, and here you can say, oh, is this one. This is what it's doing. Oh, draw a text. So with graph, it's a draw a text-based graphical representation of the commit history on the left hand of the side of the output. This may cause extra line to be printed in the between commit. In order for the graph history to be drawn properly, it cannot be combined with no walk. Cannot be combined with no walk. This enables pattern rewriting. See the history simplification. The implies the top order optionally by default, but the data order or the date order option may also be specified. Interesting.
Graph right here, and if I find the option, there's the option. Look, draw a text-based graphical representation of the commit history. Okay.
So now if you go back to this, say, hey, I want to go to the graph, and I want to go to the next one. Okay, I want to go backwards or the next one, which is the command. Interesting. Okay, cool.
It's good to know we have that. All right, and then we can go decorate. Let's find the option.
Exactly, and if we go to now to decorate, we're going to find that option. Decorate, there you go. right? This is the option. And then you're gonna pass is that reference, the pattern. Decorate ref exclude and patterns. Oh, okay. It's interesting because it is decorate ref. Oh, and here you can pass it. It's like no decorate or decorate. You say short full auto node, print out the ref names on any commit that are shown. In short, if I specify the ref name, prefix, ref heads, rec tags, and ref remove will not be printed. If short is specified, the ref rem interesting. If short is not specified, the ref name, prefix, ref head, tags, and remotes will not be printed. If full is specified, the full ref name including prefix will be printed. If auto is specified, then if the output is going to be terminal, the ref name are shown as if short were given. Otherwise, no ref names are shown. The options decorate is shorthand. It's a shorthand for decorate short. Interesting. Which is doesn't show any of this reference name. Default to configuration, the value log. Okay, so now we're quite familiar. We can say git log, git log decorate. All right, it seems that that doesn't exist. Quite interesting. Git log decorate. Your current branch master doesn't have any commit yet. That makes a lot of sense.
May have to go backwards. Decorate often is, it's a little bit harder to read. Prints out the ref names of any commits that are shown. Probably not really sure what a ref name is. Well, remember, everything's a commit, everything has a SHA, and you can reference those commits with some sort of named item. Branches, right? Branches, tags, there you go. Or the very special one named head. We'll go over head in a little bit. All right, problem. Display the history of your repo with graph and decorate. So I'll do right now, git log graph decorate.
Oh, I never do that. They commit. That's why I say git. So now git commit those change to the index, or to the staging area, to the area that Git is going to keep track of this with this friendly message. Say friendly message, right? That's right. So now we create is the root commit, which is a node called the friendly message, and say, hey, one file add change, one insertion, create modes, which is one line, and create mode, this one with the first empty. So if we now take a look at this with the decorate with short, it now give us is without all of the ref. Okay, so it has now the first here, which is anytime you create now a commit, it will create now a SHA, the secure hashing algorithm. Let me see if that is right. A secure hashing algorithm. So you create now this SHA, secure hashing algorithm, which is a great stuff. And also it contains now the name of the author, the timestamp, and the commit names, as well as the commit, as well as the change there. So far we can only see is the commit history, but I don't know where is the change you can see. I cannot see the change here.
Decorate.
So if we now say, for example, git log
And decorate. So I'll do right now, git log graph decorate. Off.
We say git log graph decorate, and then you got it. Awesome. All right. Again, some sort of shorthands, as you can see here. Okay. Cool.
Then you don't actually have to use decorate if it's just printing out to standard in. Kind of like a little fun exercise to do. Watch this. If I go this, I drop decorate and I just do graph. You'll notice right here, head points to master, printing out to. So, fun exercise to do. Watch this. If I go this, I drop decorate and I just do graph. You'll notice right here, head points to master. If I take this and put it out to a file and then cat out the file, look at what's missing. That bit of information. So if you're ever, printing out anything to a file, you need decorate to actually get. Decorate. You need that flag to tell you, hey, list out all the named commits for me. Nice little thing. So often you don't use decorate like in practice because you're just looking at the log. Just something to be aware of. Unfortunately, we only have one commit, so the graph option really isn't like super fantastic, right? Like you're not actually seeing a graph, there's nothing to graph, but you'll notice that there's like this little asterisk right here. And that little asterisk is your only node in the graph. So that's the...
If you look at, for example, log here and say graph, right? Without the decorate. But if you want to now print that out into something, here, git log graph. That's interesting. And you say cat out. You see that you got is this. That's interesting. It's like what is the Okay. That's quite interesting. Okay. Anyway, but I just want to know about this, and this is part of the operators. This exactly. This is part of the operator. Is a redirection operator that redirects the standard output of a command to a file. So git log generate a graphical representation of your git commit history, redirect that output to is a destination file that will contain the output here. Instead of displaying the git log in the terminal, the output will be reading to a file named out. It's because it redirects the output. If the file doesn't exist, it will create it. If it already exists, its contents will be overridden. If you put now this, it will append to the end of a file. If you put this, to redirects error output standard error, and redirects both standard output and error output. If you current example, after running the command, you can view the content of the out file using commands like cat out or less out. But it redirects that output. Interesting. Git log graph redirect that output to out, it didn't create any file here, which is, I know it did it. So redirect that output to this particular file.
In practice, because you're
Okay.
just looking at the log. Just something to be aware of. Unfortunately, we only have one commit, so the graph option really isn't like super fantastic, right? Like you're not actually seeing a graph. You're just, there's nothing to graph. But you'll notice that there's like this little asterisk right here. And that little asterisk is your only node in the graph. So that's the beginning of the graph item when you use log. We'll look at it a lot more. All right. Hopefully everybody's on the same page at this point. So we're going to now get into some of the Git internals, right? We're going from 0 to 15, and then we're just going to jump right in at like 200 miles an hour. So we're going to go all the way in. Again, SHA.
Okay. Git internal representations. Let's get into this, right? But this is not Git internals representation. Representations, right? There you got it. Git internal representations. This is part of this course. Okay. These internal representations. Oh, we're still in the configuration. Oh, we're still in the configuration, love. Okay. Get internal representation.
Internals, right? We're going from 0 to 15, and then we're just going to jump right in at like 200 miles an hour. So we're going to go all the way in. Again, SHAs, they're just a 0 through 9.
But that's interesting. Oh, exactly. A bit of plumbing. Get internal representation. Okay, to understand the Git, you must go past the porcelain and check out the plumbing.
A through F, string of characters, 40 of them. And so now we're going to do the plumbing part. I'm very excited.
Okay, this is part of the plumbing side. Okay. A bit of plumbing. A bit of plumbing. So what's going on behind the scenes? A bit of plumbing. Okay, so SHA git commits come with a SHA. So SHA. So git commit comes with a SHA. With a SHA secure hashing algorithm. A hash with O to 9 and A to F characters. Okay. A hash with O to 9 and A to F characters. Alright. You can specify the first 7 characters of a SHA for Git to identify what you're referring to. Okay. To get the SHA of a commit, we can use the log command and copy the long hex string.
By the way, just so you know, you can specify the first 7 characters of any SHA, and Git will resolve that out. So you just need to get at least the first 7 characters.
So in Git will resolve that out. So you can specify the first character of the SHA for Git and identify what you're referring
to be able to get.
Interesting. Very interesting. So you can specify the first 7 characters of that, and then Git will know what to reference. What do you mean to? Okay.
Out your SHAs. There's other ways to get out SHAs, but log is like the simplest way. You don't have to know this one special command for getting out a SHA. Instead, you can just use log. It's a problem. Find the first commit SHA of your first commit. And I want you to copy it to your system clipboard.
Okay.
Now, this is the important part. Everybody has to do this, okay? Because now we're doing the internal. So get the SHA. So I'll go git log. And I can come up here and I can.
Exactly. So here what I can do is to say git log. All right. By default is decorated as that. Go into that. What I can have access to? What I can have access to?
Has to do this, okay? Because now we're doing the internal. So get the SHA. So me, I'll go git log. And I can come.
Okay, git log. And that doesn't allow me to get in. Git log. What? Interesting. Search for A. But it doesn't allow me to access through. That's not good. Yeah, but how can I access from warp to that? Okay. To my clipboard. Okay, git log. And it doesn't allow me to have access to.
I'm up here and I can. The important part, everybody has to do this, okay? Because now we're doing the internal. So get the SHA. So me, I'll go git log, and I can come up here and.
Yeah, it doesn't help me. But it doesn't allow me to move through that. Okay. As you wish, my friend. Anyway, and you say BB copy this one.
All right. There we go. So I have it nicely on my clipboard right now. Quick question: why is your SHA different than mine? Mine is 8, 7.
Exactly. Why your SHA is different than mine? Because it's a combination between the author name, the timestamp.
2, 1, A. Yours is probably not any of that. Why is it different?
Different inputs. Not just based on the like one markdown file, but also your like user.name, .email, maybe other environmental vars.
Exactly. So you pretty much got the idea. My SHA is based off what I committed, the time of the day, my username, my email. So I should produce a unique one comparatively to you. So if we both, at the exact same time of the day, both committed the same thing, it should produce different SHAs. So because it's an amalgamation of a bunch of different options. So just so if you're wondering, you can't follow along directly. You won't be able to just use the SHA.
Exactly. So that's different based on the date, the author name, the content change, is an amalgamation of all of this stuff. All right.
SHA that's produced, you'll have to be able to grab out your own. All right, so the next part will be a little bit hard, but I think you can try to give it a shot. Do you think you can find your SHA in the Git folder? Why don't you take a look? Go in there.
Okay, that's a very interesting problem here. Diving into the commit SHA. Diving into the commit SHA, or in other words, can you tell me exactly? Can you tell me how to access the Git commit from your .git folder? That's a very good question.
Remember, the SHA is what you're looking for. Just do a little perusing on your own for a minute.
Okay. So, because the folders live here under the Git, and since we have now is the commit, which is this one, now I can look at this and say, hey, we have now is that's not our commit. Our commit is quite different to that. But that's interesting. It ends with this. Oh, look at this. Oh crap. Okay, X6 is this one. The question is that why it create all of this, since at the end of the day I just only have one. So you have now the info and the back and all that kind of stuff. So how you can have access to this? You can say cat, so git cat file of the .git object A6 and the name of the SHA, and it tells me that's not what it is, but no problem, no problem. But now where we can look at this is that we have the commit, the index, the ref, all of the hooks, the description, and now this. But what is the format of this file? You know? What is the format of this file? Because I know where to look, I know what it is. Okay, because it ends with this. And the first two characters, now it takes that as part of the file. And then the rest of it.
I'll give you another hint. The first two characters of the SHA are important.
Yeah.
So look around. Maybe try the find command. Find's a great one. It'll list out a bunch of files for you.
Yeah. So the first two, the first two characters in the commit are important. Git creates a file based on that, and that's quite interesting. For commit.
All right, I'll just kind of start doing it. So if I go like this, find, remember when I did it before, there wasn't a ton of files. But if I do it again, notice now we have a whole bunch of stuff inside of objects now. And not only that, but there's my 8.7. There's my 2.1a. Look at that thing. That's my commit, right? That looks like my commit. You have your commit somewhere in there, and you can go and find it. It's a real thing, right? Little quick observation. Everything inside the git.objects, or sorry, .getObjects directory will have the first two letters of any SHA that is being tracked by Git, and you can use that to find stuff if you're to manually look through Git. All right, that's where they're all stored. That's where all of your changes and everything are stored. So, by the way, I absolutely love. This is like my favorite part of The Hobbit was the what's in its pockets. You know, I just love that part. For those that don't know, it's a fantastic scene where Bilbo has the ring and needing to ask riddles, and if he gets a riddle wrong, he gets eaten. And his last one isn't a riddle. He just said, "What's in my pocket?" And then Gollum goes crazy, and that's the whole story. That's how Lord of the Rings happened, is because he wouldn't tell him what's in his pockets is. It's crazy. Anyways, all right, so if I were to go here and say git objects 8.7 and cat this thing out, it's a bunch of nonsense. You can do the same thing, right? You can't understand that file or this commit from just catting stuff out. It's been kind of like, it's been compressed, so it's more space efficient, so it's just nonsense to our eyes. Here's my version right here. Remember, all of git state is stored in these files, all of it. So that's why our commit's there. All right, so some of the tools of a plumber, there's a bunch of different ways you can like manually.
Okay, this is the tool of the plumbers. So the tools of the plumber,
manually use the right git command to print out the contents of stuff, but there's also catfile -p, and that will just print out any SHA you want and the contents of that SHA.
Okay. So here, this git cat file. So git cat file, and the file, of course, or the SHA. And the SHA here. So we'll print any commit or SHA file. Let me actually dive deep into this, if this is real. To say and some SHA.
And so there are like, if you actually use the actual git commands, there's like a tree one for printing out trees, there's one for printing out specific parts, or just this one. I prefer just to use this because it's kind of annoying to have to know all the little subcommands. I'm sure there's like a cost to it, which is like Git has to figure out which SHA you're actually talking about and the type of SHA, and then to uncompress it and to give you this nice view and all that. But just use this. You can inspect any commit or anything about Git by using git catfile -p. So I want you to catfile your SHA and see if you can get to the point of being able to get the contents out of first MD.
Okay, so it's going to get the contents out of our fields of this. But it tells me, oh, because you need to pass this a SHA for that. And the SHA is this. It's not the file, it's not the directory, it's the SHA. This is not the SHA. Git log. Is this one? That's right. So you say git cat file with a P and the SHA. It now give you is this. The author who made this commit, the name, okay, and the timestamp. The author, the committer, the SHA in the tree. Remember that at the end of the day, this is an acyclic graph, and as well as the commit.
See if you can actually get all the way down and find it by just catting out your SHA.
So in my case, yes, I did.
I will now do this. So I'm going to go like this. Get cat file -p. I'm going to print it out. Look at this. It has a tree. What's a tree? It has the author. It has the committer. It has the time. It has, I don't know, 0600 on it. It has my friendly message involved right here. Where's our commit, though? This doesn't tell me anything. So there's another SHA here. So I'm just going to grab that SHA. Whoopsies. And I'm going to just put it in. Look at this. Again, something that looks like file permissions. Blob. Another SHA. And look at that, the name of the file we just got done adding. So it kind of looks like we can kind of walk through Git, and we can find the file that it stored. So I'm going to go here now, and I'm going to do the exact same thing. I'm going to print out that, and look at that, hello front-end masters. I was able to go all the way down and drill to the exact point of the change we've made by starting with the Git SHA. This is very, very important. Now, there's some really good key terms here that you need to know to the exact point of the change we've made. The exact same thing. I'm going to print out that, and look at that. So it kind of looks like we can kind of walk through Git, and we can find.
Exactly. So what we're doing is just to walk through Git. All right. So what is a tree? Let's going to find that out. So you say git cat file -p with that commit, with that hash, or with that SHA, secure hashing algorithm. Okay. And then you got is this, and once you point that, interesting because this has now some sort of ID number, blob, the hash, and the file here. And if you continue to go in up to that, which is git cat file -p, is this one? Is a hello fan. Oh, so you can now walking through all of this. Okay, that's interesting. Okay, I love it. I love it. If we follow up the SHA or the commit, we can now walk through the exact. So we can now walk through the. So we can now walk through Git. Exactly. So we can now walk through Git tree or graph to okay, because it's holding all of this reference here. So we can now walk through Git graph to give us the content of our changes.
The file that it stored. So I'm going to go here now, and I'm going to do the exact same thing. I'm going to print out that, and look at that, hello front-end masters. I was able to go all the way down and drill to the exact point of the change we've made by starting with the Git SHA. This is very, very important. Now, there's some really good key terms here that you need to know. First off, you'll notice that there's a tree, right? You see the term tree being printed out. The easiest way to think about tree is a directory. it contains a set of files or more directories. A blob, which you saw right here, is a file. And so that's kind of the mentality you should have if you ever look or peruse through these commits. And we will actually use this information later and restore stuff that we've lost by knowing this kind of information. So anyways, there we go. We were able to go all the way down to the bottom. So that means our SHA contained a tree, and that tree...
Exactly, that SHA contains a tree, and that tree contains a file.
Contained our file, and that file
And that file contains our entire content.
contained the entirety of that file.
So that SHA, so that commit SHA contains a tree, goddamn. So that commit SHA contains a tree SHA that contains the file SHA, or the file blob that contains the file. So that commit SHA contains a tree, a directory of files SHA that contains the file, and that contains a blob to the file SHA, and then contains a SHA blob, and that contains a SHA blob to the file that contains the content. And this is interesting, this is important, because we're going to use this information and this is important because that contains information that we're going to use to restore that.
Not just, that means our SHA contained a tree, and that tree contained our file, and that file contained the entirety of that file. Not just our changes, but the entirety of the file. So here you go. Very key concepts. Make sure you know that. Big takeaway, Git does not store diffs. And we're going to prove that.
Exactly. Git does not store this.
It stores
Complete
the entirety of stuff.
Versions of
And
the
so I want you
entire
to take a
stuff.
really, just take a moment and remember this SHA, maybe by the first couple characters. Mine's EC3. You just remember yours. This is the SHA to the file. This is a very important part right here. All right, so we're going to do something else. I want you to create a second file.
Exactly. Git store now, not diff, is the complete content of the file.
And I want you to commit it and call it second.md. Whatever text you want, just create something. So I'll do the exact same thing.
Okay. Pretty straightforward here. You say git log. Okay. Let's git status. Now I want to remove this. So like out. Right. I want to create now a second MD. I'm gonna create git. Let's say touch second MD, second.md. All contain is full bar, right? And then I want to now get status, which is to look at that. Oh crap! I get it. Git remove in a recursive force way of bar, as well as foo, as well as second. That's interesting. Now it is there. If I open up here with code, it has these two files. Okay. Then I want to say nanosecond, say full bar. Please save this, and then git add the second, and then git commit. Would say, hey, this is the second commit, a full bar. Okay, this is now the full bar. It create now a new change, or it create now a new node on the graph. That will contain is that.
All right, fantastic. Hopefully everyone mostly got that done. Just make it a quick, easy change. By the way, I do want you, if you're using like some sort of command line utility, or you're using your editor, if you're using VS Code or Vim, don't use the Git client. Right now, we're going to stay all in the command line. And I want you to be there for a reason, because you want to understand what's actually happening. Because when you use something like Fugitive for Vim, it's literally just translating your actions into these command line arguments. So I just want you to understand what's happening here. All right, explore your new commit. What can you say about firstmd in your new commit? Because we didn't touch firstmd, did we? We didn't. We just simply added a new file and then committed it. So can you find firstmd in your new commit? By the way, little fun fact, you get the first 7 characters right here whenever you commit. So you can actually copy that and go git cat file -p, throw that in there. All right. Notice something a little different here. We have a tree.
Now how we
Again,
have a tree.
Remember, this is your folder, but we also have a parent.
We have a
And notice that-
pairing here. So what happened when we add a new file to our commit, or to our track stage area, right? Now the git log looks quite different. So in my case, it looks like this. If you say git log, now I have this. Oh, but if I say git log decorate, if I say git log graph decorate, or if I say in this case, okay, then if I say git git cat file, say git cat file of the first 3, 6, 7 files or numbers here, you're gonna get this. Okay. And then we got this.
That is the SHA for my first commit. It will be the SHA from your first commit. You can start seeing how this graph is being born. Your first one doesn't have the parent, the next one does, and from here on out, they'll all have parents or multiple parents. Second, let's take this tree, and I'm gonna cat this out. Get cat, there we go. Now look at that. Oh, I actually have out. I actually committed out. You know, remember when I showed you the log, I didn't look at what I was doing, I actually committed out. Mistakes were made, but either way, you see this right here. You see that I have both my first and now my second. But remember this very important part. Look at what first is. It's the same SHA that it had in the previous commit, meaning our commits store pointers to the entire contents of that file. So we did not update first.
So for example here, if we say git what if we say git cat file of that git cat file, make it a git cat file, but from that, and then I say git cat file of the parent, which is on the tree, all right, which is on the tree. And then you have now is it has 2 pointers. Look at this. Okay, it now has 2 pointers to the first and the second here. And if you remember that the previous log in this cat file was like that, so cat file the SHA contains now the hello fam, which is this one. And then the second one. Okay, so now the tree contains now 2.
Therefore, this next commit contains first, but it contains a pointer
Pointer.
to the exact version. That means at any point in time, you only need 1 commit to rebuild your repo. You can completely rebuild everything about it, because that is how it works, is that every single commit stores the entirety of the state, not a differential. And this is a very important point about Git, because it just helps you understand Git fundamentally.
So git now
So as you use
points
merge and
holds
rebase and all
the
these other commands,
entire-
it's just good to know this. Does this generally make sense? Even if you don't understand how the compression works, how does it look up stuff? Do you at least understand that Git stores these files, stores them as a bunch of these really long strings of characters, and those long strings of characters contain every last change of your repo? Question.
So the first 2 characters of a commit's SHA is then placed where those blobs are for each file, so that points to the commit that it was last updated in.
Effectively, yes. And so you can see right here, if I look at that, EC, if I go L,
So that characters of a commit's SHA
long strings makes sense. Even if you don't understand how the compression works, how does it look up stuff? Do you at least understand that Git stores these files, stores them as a bunch of these really long strings of characters, and those long strings of characters contain every last change of your repo?
And those long
Question.
strings of
So the
characters
first 2
contain is the
characters
file
of
content.
a commit's SHA is then placed where those blobs are for each file, so that points to the commit that it was last updated in.
Effectively, yes. And so you can see right here, if I look at that, EC, if I go ls git objects, you'll see EC.
DC.
So you actually see that it literally is storing each thing, and then it builds it up. Every tree contains effectively 1 or more blob, is the way to look at it. That's why you can't commit an empty folder. Have you ever created a folder and then nothing shows up?
Exactly.
That's why, because the tree has to have something.
And Richard says, is this like a linked list?
That's a good way to think about it. It's like a linked list. The problem about a linked list thought is that a linked list contains a node that points to the next node. But Git, you can have more than one parent. It's an acyclic graph
It's an
that
acyclic
happens to be
graph.
linear. Is probably the best way to look at it. Is that there is an unironic order to Git, which is time, right? So as time marches forward, every commit you make is ordered that way.
But it's
That's actually an
just storing
extremely
the
important
entire
point to make
content
sure you
of
have in your
that.
head, because when we do bisecting, time is a very important aspect to it, and why bisecting works very, very well. And if you've never used bisect, I'm very sorry if you've ever had to find when a bug happened and you didn't know that this tool exists. So we'll go over it. Hopefully this does make Git feel less magical, though. I want Git to feel magical because it works so well, not because it's mysterious. And that's where you want magic to happen. You want it to be a great product, not mysterious that it actually works. Sometimes it's mysterious that it actually works because you programmed it and you're shocked that you can build anything that big. That's a different story. You know, the previous chief product officer at Netflix said, "I'm surprised Netflix even works at all." Right? Like, because at the end of the day, it's a whole bunch of people building something, and somehow it all works together. So it's always fantastic. Remember, every single program you'll ever write can be broken down to a bunch of if statements, for loops, and variable declarations. Like, that's it. That's all you're doing. Really, if you really break it down, it's just a bunch of go-to statements and procedural
goes
code.
to
Like, that's all you write.
for loops
And so
and
no matter
that.
how fancy, no matter how much elixir you use, it's all just really simple go-to statements at the end of the day. All right, this is just for you guys. I'm gonna do a little quick thing right here. I'm gonna go like this: make dir, how about source, get status, You'll notice nothing shows up. I'm gonna go vim source, and we're gonna create a file in here. How about index.js for all my, TS, we're just so awesome, right? Am I right? Okay, I'm gonna have an empty file in there. Get status, you'll see that it's right there. Get add this, get status, get commit, foo, I'll do foo again. And I have this right here. I'm gonna go get cat file dash p and print it out. Again, parent, previous commit, tree. I'm gonna go into the tree. Get cat file dash p tree. Look at this, we got our blobs, but there you go. Another tree right here, and that tree is a folder. So that means if I take this tree and go get cat file that tree, you'll see index.ts. It's literally just storing a bunch of pointers describing the state of Git. Just really to drive that home, just so everyone really understands. Like, you could probably build a command line tool that cats out a commit, parses out these strings, and you could probably rebuild the repo yourself, just from knowing how to use git cat file. You could actually rebuild the entire state of it by just walking blobs and trees.
Okay, that was interesting, and that'll be all for this video. Take care. Bye bye.